हाय एवरीवन, वेलकम टू मैथमेजेस्टिक। आज हम करेंगे क्लास 10 चैप्टर 1 रियल नंबर्स की एक्सरसाइज 1.2, जिसमें हम प्रूव करेंगे irrational numbers, how we can prove them irrational numbers. In the class 9th, we have done the definition of rational and irrational numbers. So rational numbers are basically the numbers which can be written in the form p by q, where p and q are integers and q is non-zero, and the rest of the numbers are called irrational numbers. Now, or in other words, if we talk about irrational numbers, so irrational numbers are the numbers which are non-terminating and non-repeating as well. Or we can say that if the number cannot be written in the form p by q, अगर आप उसको नहीं लिख सकते p by q की फॉर्म में, where q is non-zero and p and q are integers, so then also we call them non-rational or irrational numbers. And the well-known examples of irrational numbers which we have done so far is root 2, root 3, root 5, root 15 or pi. These all are irrational numbers. Now we will prove them, the irrationality of these numbers, how we can prove. So we will take the help of fundamental theorem of arithmetic in this, which we have done in the previous exercise. If you have not seen that video, so please, I will send the link in the description box of the previous video. So first go through that fundamental theorem of arithmetic in the previous video, then you will get the better idea of the concept. So first, with the help of fundamental theorem of arithmetic, we will prove a theorem that will be helpful to prove the irrationality. And the statement of the theorem is, let p be a prime number if p divides a, then p divides a also, where a is a positive integer. So अगर कोई प्राइम नंबर किसी a स्क्वायर को डिवाइड करता है तो वो a को भी डिवाइड करेगा, where a कोई भी इंटीजर हो सकता है, पॉजिटिव इंटीजर. So first we will prove this result with the help of fundamental theorem. So in the fundamental theorem, we can write any number as the product of the primes. Let we write this a as the product of the primes, like p1, product of the primes p1, p2 up to pn. These are, suppose, n prime numbers p1, p2, p3, p1, p2 up to pn. These all are prime numbers. They are different prime numbers, I will say. So suppose a can be written as the product of the primes. Now these are not necessarily distinct primes, because suppose 18 is a number. So what will be the prime factorization of 18? 2, 3s are 6, 3s are 18. 2 and 3 are prime numbers. 3 is repeating here. So we cannot, here similarly p1, p2 are, these are prime numbers. So it is not necessary that they will be distinct. Here 3 is repeating twice. So all the prime numbers are not distinct here. Similarly, these are not necessarily distinct here. Now if we have to find a square, so what we will do? We will multiply these numbers p1 up to pn. Twice we will do the product up to pn. So how we can write p1 square? p2 is 2 times multiplied. Similarly up to pn, this is twice multiplied. So we will get this. So now we are given that p is a prime number that divides a square. We are given this, that p divides a square. We are given this, p divides a square. So now फंडामेंटल थ्योरम ऑफ अर्थमेटिक, p अगर a स्क्वायर को डिवाइड करता है, सो दैट मीन्स p शुड बी वन ऑफ द फैक्टर ऑफ a स्क्वायर, बिकॉज कोई भी नंबर अगर किसी को डिवाइड करता है तो दैट शुड बी द फैक्टर ऑफ दैट नंबर. सपोज 18 को अगर हम ये कहें कि 2 18 को डिवाइड करता है तो 2 इज़ अ फैक्टर. अगर हम कहें 3 18 को डिवाइड करता है तो 3 इज़ अ फैक्टर. 6, सो 6 इज़ ऑल्सो द प्रोडक्ट ऑफ द फैक्टर. सो अगर कोई भी नंबर है उसके डिवाइजर्स जो होते हैं वो उसके फैक्टर्स भी होते हैं. तो अगर p a स्क्वायर को डिवाइड करता है, देन इट मीन्स दैट p is a factor of a square. That means, and we have done here that these all are the factors of a square. p1 square, p2 square, these are all the factors of a square. That means p is also one of these factors. Any one of this is equal to p. It means this. So that means, so p is factor of a square. So p is one of prime factors of a square. Among these P1 P2 अप टू Pn, इनमें से ही कोई P भी होगा. इसका मतलब क्या हो गया? So we realize that P is one of P1, P is among P1 P2 P3 up to Pn, इनमें से कोई एक वैल्यू P के इक्वल है. Now we are given that A is equal to P1 P2 up to Pn. Product of these factors of A are these. So अगर P भी इनमें से ही कोई एक है, that means P is also a factor of A. P A का ही एक factor है, and factor है तो that means P will divide A. So if P divides A, that's what we want to prove. We have taken that P divides A square here, and we have proved that P divides A. It means that P divides A. This is the notation to write P divides A. So that hence we have proved using the fundamental theorem of arithmetic that if a number P divides A square, so that means P will be the factor of A square, and only factor of A squares by fundamental theorem are P1 P2 up to Pn. So that means P is one of the value of these P1, either P1 is P, either P2 is P or P3 is P up to Pn. कोई भी नंबर P के इक्वल हो सकता है. और बिकॉज ये आपको दिया हुआ है कि A is a product of P1 up to Pn, so that means P और P इनमें से कोई एक है, that means P A को भी डिवाइड करता है. तो that we wanted to prove that if P divides A square, so P will also divide A. Now we will use this result to prove the irrationality. So let's prove the irrationality of square root of 2 first, because it is the most easiest, most common example to prove the irrationality. So now we will prove first, that is very important result, root 2 is irrational. We will prove this. So now we will use there are different methods in mathematics to prove the theorems. So one of the method is proof by contradiction method. In this method we will assume the reverse of what we want to prove. Here we want to prove root 2 as irrational. So we will take this as rational number, and in the end we will prove the contradiction. So let's take that root 2 is equal to A by B. That means rational number. So A by B. If a number is rational, that means A and B. Simplest form of the rational number we will take. इसका मतलब A और B दोनों co-prime numbers होंगे. Co-prime, that means they do not have any factor common other than 1, and B is non-zero. Because this is a rational number, so definition of rational number states that denominator is always non-zero, and this is the simplest form, that means they do not have any factor other than 1 common. So that means A and B are co-prime numbers. Now what we can do, cross multiply this, so root 2B, that will be equal to A. Doing the square on both sides, if we will do the square here, so root 2 square will be 2B square, that is equal to A square. Squaring both sides, we will get this. Now it means that A square has two factor, 2 and B square, and because as I gave the example earlier, 2 3s are 6 3s are 18, that means 2 will divide 18, 3 will also divide 18. Similarly 2 and B square are the factors of A square, so it means that 2 divides A square. It means this 2 divides A square. And now just we have proved the result. If कोई number अगर A square को divide करता है तो वो A को भी करेगा, hence 2 divides A also. That's why we proved the result earlier. अब 2 अगर A को divide करता है, इसका मतलब क्या हो गया? अगर मैं कहूँ कि 3 18 को divide करता है, that means 3 is one of the 18 is the multiple of 3. If I say you that 3 divides 18, so can I write this like this, multiple of 3? So now similarly अगर 2 A को divide करता है तो we can write A as the multiple of 2. So multiple of 2, that means 2 will be multiplied by some number. So let's take that number as C. Like here we have taken 6, so we will take this as C. 2 divides A, that means A is a multiple of 2, where C we have taken C is any integer here. Okay, like in this example we have taken 6 as an integer, multiple of 3. Here we have taken C as an integer, multiple of 2. Now put this value of A sorry, in this. Again we will put the value here. So A is equal to 2C. If we will put A value here, so what we will get, 2B square is equal to, this is A square, so square of this will be 4C square. We will put this value here now. So 2B square is equal to 4C square. 2 we will cancel both sides, so we will get B square is equal to 2C square. Now This means again we will do the same process. We got two factors of b square as 2 and c square. That means 2 divides b square. Because factors जो होते हैं वो number को divide करते हैं, तो 2 divides b square. Now again we will use the theorem result. अगर 2 b square को divide करता है तो 2 जो है वो b को भी divide करेगा. Now what conclusion we got? 2 divides a and 2 divides b. That means 2 is the common factor of a and b. But what we have taken in the starting that a and b are co-prime. They do not have any other factor common other than 1. But here we proved that because 2 divides a and 2 divides b, so 2 divides a and b both. That means 2 is a common factor here of a and b, which is a contradiction. Common factor of AB, which is a contradiction because we have taken A and B are co-prime. So contradiction हो गया हमारे पास यहाँ से. Contradiction to A and B are co-prime. इस statement के साथ इसका contradiction हो गया. So that means whatever we have taken, root 2 is a rational number. That is wrong. It means that root 2 is irrational number. This is one of very important method in mathematics to prove the theorems, to take the contradiction statement. Okay, so now similarly we can prove the irrationality of any number. Similarly you can prove the irrationality of root 3 also. Now in the class 9th we have done the very 2-3 results regarding the algebra of rational or irrational numbers. Like suppose we have done that sum of two rational numbers and irrational, sum of irrational and rational number. If we talk about some result, sum or difference, दोनों के लिए result है ये, sum or difference of rational plus or minus irrational number. If one number is rational and another is irrational, so that means the result will always be a rational number. And if we talk about non-zero rational number and irrational number, their multiplication और division, इनमें से कोई भी एक हो सकता है. अगर आप नॉन जीरो रेशनल नंबर हो और दूसरा एक इरेशनल नंबर है, उनको मल्टीप्लाई करें या डिवाइड करें, देन ऑल्सो आंसर विल बी इरेशनल. हेयर इफ यू विल टेक हेयर रेशनल नॉन जीरो वर्ड अगर हम यहाँ से हटा दें तो वी कैन टेक जीरो ऑल्सो. एंड अगर आप जीरो से किसी को भी मल्टीप्लाई करेंगे तो आंसर जीरो ही आएगा. तो दैट इन दैट केस आंसर बिकम्स रेशनल. इफ यू मल्टीप्लाई अ रेशनल नंबर बाय इरेशनल नंबर, इट इज नॉट नेसेसरली irrational. It can be zero also. Okay, so that's why to just mention, we will mention here, if we talk about non-zero rational and irrational numbers, so result will be irrational always. Okay, so sum and difference of rational irrational is irrational always, and multiplication division of non-zero rational and irrational is also irrational number. So now we will prove, in the next example we will prove the similar things, addition subtraction of rational numbers as an irrational number. We will prove this. Suppose 5 minus root 3 is irrational. Suppose we need to prove this 5 minus root 3. Now example 10 we will do 5 minus root 3 is irrational. This we need to prove now. So again we will use the contradictory result. Let's take 5 minus root 3 as the rational number. So let 5 minus root 3 is rational. अगर ये rational है तो that means we can take this as equal to a by b. Suppose a by b is a rational number, a and b are integers and b is non-zero as per the definition of rational number. So now we will do the cross. Now what we will do, we will shift this root 3 on the one side and 5 on the other side. So root 3 we will shift there. 5 minus a by b is equal to root 3. Now we know that root 3 is an irrational number. So if we will prove this rational, so they can't be equal. Rational cannot be equal to irrational. So our result will be contradictory result. So we will take, that means our assumption will be wrong and we will get this as irrational. So now a and b, राइट साइड जो है दैट इज कंप्लीटली वी नो इट इज इरेशनल. √3 is irrational. We can prove it as similar to √2. Now we need to prove this. We will find out this number's behavior. 5 minus a by b. Now a by b is a rational number. a by b we have taken as rational here. So 5 में से अगर किसी rational number को subtract करेंगे तो that will again be a rational number. Okay, so left side is rational and right side is irrational here. That means it is a contradiction. It cannot be possible that rational and irrational on the one side rational, another side irrational. So that means it leads to a contradiction to the result that 5 minus √3 is rational. This is contradiction. So hence 5 minus √3 is irrational number, not a rational. Similarly, you can prove the irrationality of any number. Now, similarly, this is the result for the sum or difference of the rational number. Similarly, you can prove the result for multiplication or division of a rational and irrational number. So, how you can prove that? By the example 3√2. Suppose multiplication of a rational number 3 and √2 irrational. So, we will prove that this product is also irrational. So, contradiction we will take. Suppose this is rational. So, we will take this equal to a by b, where a and b are integers and b is non-zero. Now, what we will do here, 3 we will shift here in the denominator. √2 on the one side, 3b here. Now, √2 we know that it is irrational. We have proved it earlier. Now, we will prove this. Now, a by b is rational number as we have taken here. So, अगर आप rational को 3 से divide करेंगे तो that will be again rational. So, right side is rational. Again, we got the contradiction. Left side irrational, right side rational. It is not possible. That means our assumption is wrong. 3√2 is irrational number, not a rational number. It is very easy to prove the irrational number. Similarly, we can do the exercise questions also. Suppose in the exercise, NCERT exercise 1.2, question number 1, that is √5 is irrational. So, we can prove √5 irrational. Similarly, we can prove this irrationality. How? Suppose let's take √5 as a rational number a by b, where a and b are integers and b is non-zero. Now, what we will do, as in the previous question, we will do that, do the square b, we will shift here, √5b is equal to a, we will do the square on both sides, so it will be 5b square is equal to a square. That means 5 is a factor of a square, so it means that 5 divides a square, because any factor of the number also divides the number. So 5 divides a square. Now we have done one result. अगर कोई भी number a square को divide करता है, कोई भी prime number, तो वो a को भी divide करेगा. That means 5 divides a also. अब अगर 5 a को divide करता है, तो that means a is a multiple of 5. That means 5 can be written as a can be written as 5 multiplication some number. Suppose as I gave the example of 18. Factors of 18 are these. So, if 3 divides 18, so we can write 18 as multiple of 3. Similarly, here a can be written as multiple of 5. Suppose that multiplication number is c. C is another integer here. Any integer. Now, we will do this. A is equal to 5c. We will put this value here. So, we will get 5b square is equal to a square. A square means square of this 25c square. Now again 5 we will cancel on both sides, so you will get this b square is equal to 5c square. Now again the same process will be repeated, because 5 and c square are the factors of b square. So 5 will divide b square. Again 5 क्योंकि b square को divide करता है, तो प्राइम अगर प्राइम कोई भी है वो किसी के स्क्वायर को डिवाइड करता है, तो वो उस नंबर को भी डिवाइड करेगा. 5 विल डिवाइड b ऑल्सो. हेयर वी गॉट 5 डिवाइड्स b. अब यहाँ हमने निकाला 5 डिवाइड्स a, यहाँ से आ गया 5 डिवाइड्स b. अगर 5 दोनों को डिवाइड करता है, दैट मीन्स a and b are not co-prime because they have more than one factor as common. 5 is also the common factor, so they are not rational, they are not co-prime numbers. यहाँ हमने दोनों को co-prime integers assume किया था, so they are not co-prime. That means our contradiction is wrong. Our assumption is wrong that √5 is rational. Hence √5 is irrational number. Hence root 5 is irrational. That is true. Similarly, as we have done the root 2, root 3, we can prove any number as irrational number. Now we will do the next question of the NCERT, that is 3 plus 2 root 5 is irrational. Question number 2, we will prove 3 plus 2 root 5 is irrational. Question 2, this is irrational number. So for this also we will adopt the same pattern as example. Suppose this is rational, so we will take this is equal to a by b, where a and b are integers. Because this is a rational number, we are considering smallest form, coprime integers, and b is non-zero. We are considering this. So now what we will do, we will shift this 3 on the other side. Root 5 will be equal to a by b minus 3. Now again root 5 we have proven in the first question that it is an irrational number in the previous question. So if this is irrational and a by b we have taken as rational number and 3 is also rational, and difference of two rational number is always rational number. So that means left side is irrational but right is rational. That is contradiction. It is not possible. Hence we got the contradiction here. So hence our assumption is wrong. 3 plus root 5 is not rational. It is an irrational number. Now we will move to the question number 3 of the NCERT. In that first part we will prove 1 by root 2 as irrational. So again we will do the same process. Let's take them as equal to a rational number a by b, where a and b are integers and b is non-zero. So now what we will do, that we will take this as, we will do the cross multiplication. So b will be equal to root 2. Now we will do the reverse. B by a will be equal to root 2 by 1. That means it is equal to root 2. Now root 2 is irrational number. We have proven earlier that this is irrational. Okay, but b and a, because a by b is a rational number, so b by a is also a rational number because both are integers, and integers को integers से divide करेंगे तो we will get a rational number. So left side is rational but right side is irrational. That means it is again not possible. So 1 by root 2 is irrational. Contradiction आ गई यहाँ भी. All the questions we will prove similarly. Now similarly the second part of this is 7 root 5. Again we will use the same method. Let's take it equal to a by b, a rational number. Now 7 we will shift here. Only the irrational number we will keep on the one side. So a by 7b we will get. This is irrational, we have proved in question 1. Again and again we are doing the same thing. Now a by b अगर कोई rational number है और 7 से अगर हम, so अगर b integer है तो 7b is also an integer. So integer को अगर integer से divide कर रहे हैं तो we will get a rational number only. This is rational. So that means again contradiction we get, and 7 root 5 is not rational, so it is irrational number. Alright, now we will do the third part. Similarly, third part is 6 plus root 2. We have to prove that it is irrational. So we will take this as rational a by b. Now root 2 is irrational, we know. So we will keep it here. 6 we will shift there. A by b minus 6. So now because root 2 irrational we know. We have proved in the example. A by b is rational. So rational में से अगर आप 6 को minus करेंगे तो again you will get a rational number only. Okay. So one is irrational, another is rational. So it is not possible again. So that means 6 plus root 2 is not a rational number. Contradiction is wrong. This is again irrational number. So hence we have completed the chapter 1, that is about the real number. In this we learnt in the first exercise about the we learnt about the HCF LCM, when we use HCF and LCM. In the second exercise we learnt about the proof of irrational numbers. So if you have not watched the first video, I will send the link in the description box. You can go there and watch that video, and if you have any query regarding any question, you can put in the comment box. And I will make one separate video of the important questions of this which are asked in CBSE board examination or different board examinations, and which are important for cases of LCM and HCF, by which you will get a better understanding when to use LCM and in which situation you should use HCF. Thank you very much.